An engine or motor is a machine designed to convert one form of energy into mechanical energy. Heat engines, including internal combustion engines and external combustion engines, burn a fuel to create heat, which then creates a force. Electric motors convert electrical energy into mechanical motion. Pneumatic motors use compressed air, and others, such as clockwork motors in wind-up toys, use elastic energy. In biological systems, molecular motors, like myosins in muscles, use chemical energy to create forces and eventually motion. Terminology. The word engine derives from Old French engine, from the Latin ingenium, the root of the word ingenious. Pre-industrial weapons of war, such as catapults, trebuchets and battering rams, were called siege engines, and knowledge of how to construct them were often treated as military secrets. The word gin, as in cotton gin, is short for engine. Most mechanical devices invented during the Industrial Revolution were described as engines, the steam engine being a notable example. In modern usage, the term engine typically describes devices, like steam engines and internal combustion engines, that burn or otherwise consume fuel to perform mechanical work by exerting a torque or linear force. Examples of engines which exert a torque include the familiar automobile gasoline and diesel engines, as well as turboshafts. Examples of engines which produce thrust include turbofans and rockets. When the internal combustion engine was invented, the term motor was initially used to distinguish it from the steam engine, which was in wide use at the time, powering locomotives and other vehicles such as steam rollers. Motor and engine later came to be used interchangeably in casual discourse. However, technically, the two words have different meanings. An engine is a device that burns or otherwise consumes fuel, changing its chemical composition, whereas a motor is a device driven by electricity, air, or hydraulic pressure, which does not change the chemical composition of its energy source. However, rocketry uses the term rocket motor, even though they consume fuel. A heat engine may also serve as a prime mover, a component that transforms the flow or changes in pressure of a fluid into mechanical energy. An automobile powered by an internal combustion engine may make use of various motors and pumps, but ultimately all such devices derive their power from the engine. Another way of looking at it is that a motor receives power from an external source, and then converts it into mechanical energy, while an engine creates power from pressure. Devices converting heat energy into motion are commonly referred to simply as engines. History. Antiquity. Simple machines, such as the club and/or a prehistoric. More complex engines using human power, animal power, water power, wind power, and even steam power date back to antiquity. Human power was focused by the use of simple engines, such as the capstan, windlass or treadmill, and with ropes, pulleys, and block and tackle arrangements. This power was transmitted usually with the forces multiplied and the speed reduced. These were used in cranes and aboard ships in ancient Greece, as well as in mines, water pumps and siege engines in ancient Rome. The writers of those times, including Vitruvius, Frontinus and Pliny the Elder, treat these engines as commonplace, so their invention may be more ancient. By the 1st century AD, cattle and horses were used in mills, driving machines similar to those powered by humans in earlier times. According to Strabo, a water-powered mill was built in Cabiria of the Kingdom of Mithridates during the 1st century BC. Use of water wheels in mills spread throughout the Roman Empire over the next few centuries. Some were quite complex, with aqueducts, dams, and sluices to maintain and channel the water, along with systems of gears, or tooth wheels made of wood and metal to regulate the speed of rotation. More sophisticated small devices, such as the Antikythera mechanism, used complex trains of gears and dials to act as calendars or predict astronomical events. In a poem by Ausonius in the 4th century AD, he mentions a stone-cutting saw powered by water. Hero of Alexandria is credited with many such wind and steam-powered machines in the 1st century AD, including the Aeoli pile and the vending machine. Often these machines were associated with worship, such as animated altars and automated temple doors. Medieval Muslim engineers employed gears in mills and water-raising machines, and used dams as a source of water power to provide additional power to water mills and water-raising machines. In the medieval Islamic world, such advances made it possible to mechanize many industrial tasks previously carried out by manual labor. In 1206, Al-Jazari employed a crank-on-rod system for two of his water-raising machines. A rudimentary steam turbine device was described by Taqi al-Din in 1551 and by Giovanni Branca in 1629. In the 13th century, the solid rocket motor was invented in China, driven by gunpowder. This, the simplest form of internal combustion engine, was unable to deliver sustained power, but was useful for propelling weaponry at high speeds towards enemies in battle and for fireworks. After invention, this innovation spread throughout Europe. Industrial Revolution. The Watt steam engine was the first type of steam engine to make use of steam at a pressure just above atmospheric to drive the piston, helped by a partial vacuum. Improving on the design of the 1712 Newcomen steam engine, the Watt steam engine, developed sporadically from 1763 to 1775, was a great step in the development of the steam engine, offering a dramatic increase in fuel efficiency. James Watt's design became synonymous with steam engines, due in no small part to his business partner, Matthew Boulton. It enabled rapid development of efficient semi-automated factories on a previously unimaginable scale in places where water power was not available. Later development led to steam locomotives and great expansion of railway transportation. As for internal combustion piston engines, these were tested in France in 1807 by de Rivaz and independently by the Nie-Acute PCE brothers. They were theoretically advanced by Carnot in 1824. In 1853–57, Eugenio Barsanti and Felice Mattrucci invented and patented an engine using the free piston principle that was possibly the first four-cycle engine. The Otto cycle in 1877 was capable of giving a far higher power-to-weight ratio than steam engines and worked much better for many transportation applications such as cars and aircraft. Automobiles. The first commercially successful automobile, created by Carl Benz, added to the interest in light and powerful engines. The lightweight petrol internal combustion engine, operating on a four-stroke Otto cycle, has been the most successful for light automobiles, while the more efficient diesel engine is used for trucks and buses. However, in recent years, turbo diesel engines have become increasingly popular, especially outside of the United States, even for quite small cars. Horizontally opposed pistons. In 1896, Carl Benz was granted a patent for his design of the first engine with horizontally opposed pistons. His design created an engine in which the corresponding pistons move in horizontal cylinders and reach top dead center simultaneously, thus automatically balancing each other with respect to their individual momentum. Engines of this design are often referred to as flat engines because of their shape and lower profile. They all were used in the Volkswagen Beetle, some Porsche and Subaru cars, many BMW and Honda motorcycles, and aircraft engines, etc. Advancement. Continuance of the use of the internal combustion engine for automobiles is partly due to the improvement of engine control systems. Forced air induction by turbocharging and supercharging have increased power outputs and engine efficiencies. Similar changes have been applied to smaller diesel engines, giving them almost the same power characteristics as petrol engines. This is especially evident with the popularity of smaller diesel engine-propelled cars in Europe. Larger diesel engines are still often used in trucks and heavy machinery, although they require special machining not available in most factories. Diesel engines produce lower hydrocarbon and CO2 emissions, but greater particulate and NOx pollution, than gasoline engines. Diesel engines are also 40% more fuel efficient than comparable gasoline engines. Increasing power. The first half of the 20th century saw a trend to increasing engine power, particularly in the American models. Design changes incorporated all known methods of raising engine capacity, including increasing the pressure in the cylinders to improve efficiency, increasing the size of the engine, and increasing the rate at which the engine produces work. The higher forces and pressures created by these changes created engine vibration and size problems that led to stiffer, more compact engines with V and opposed cylinder layouts replacing longer straight-line arrangements. Combustion efficiency. The design principles favored in Europe, because of economic and other restraints such as smaller and twistier roads, lent towards smaller cars and corresponding to the design principles that concentrated on increasing the combustion efficiency of smaller engines. This produced more economical engines, with earlier four-cylinder designs rated at 40 horsepower and six-cylinder designs rated as low as 80 horsepower. Compared with the large-volume V8 American engines with power ratings in the range from 250 to 350 horsepower, some even over 400 horsepower. Engine configuration. Earlier automobile engine development produced a much larger range of engines than is in common use today. Engines have ranged from 1 to 16-cylinder designs with corresponding differences in overall size, weight, engine displacement, and cylinder bores. Four cylinders and power ratings from 19 to 120 horsepower were followed in a majority of the models. Several three-cylinder, two-stroke cycle models were built, while most engines had straight or inline cylinders. There were several V-type models and horizontally opposed two- and four-cylinder makes too. Overhead camshafts were frequently employed. The smaller engines were commonly air-cooled and located at the rear of the vehicle. Compression ratios were relatively low. The 1970s and 1980s saw an increased interest in improved fuel economy, which caused a return to smaller V6 and four-cylinder layouts, with as many as 5 valves per cylinder to improve efficiency. The Bugatti Veyron 16.4 operates with a W16 engine, meaning that two V8 cylinder layouts are positioned next to each other to create the W shape, sharing the same crankshaft. The largest internal combustion engine ever built is the Wärtsilä Sulzer RTA96C, a 14-cylinder, two-stroke turbocharged diesel engine that was designed to power the Emma Maersk, the largest container ship in the world. This engine weighs 2,300 tons, and when running at 102 RPM produces 109,000 bhp, consuming some 13.7 tons of fuel each hour.